So here we are at our final topic in this unit, and that is adding and subtracting of scientific notation. So let's take a look at what it looks like. Adding and subtracting, you must have the same exponent. So it's kind of like terms. When we combined our like terms, our same variable with the same exponent. Well, we're not always going to be given it that way. So we have to use that LARS that we talked about yesterday so that we can get the exponents to be the same. How do I do this? Well, once my exponents are the same, I add or subtract just the number, and I keep my base of 10 with the same exponent. So it's just like terms where you would add the coefficient and then write the variable. So think of our 10 to the power of whatever is a variable this time. Now at the end, you might have to use that LARS again to bring the decimal point properly back so it's written in scientific notation. Let's see what that looks like. So what I want you to remember is the LARS. Okay. Left, we add. Right, we subtract. And what are we talking about adding or subtracting from? This is from the exponent. This is always from the exponent. So when I'm dealing with positive exponents, so here I have a 3 and here I have a 2. I'm adding these two numbers. So I need to get them to be the same. So when I'm dealing with a positive exponent, my advice would be figure out which one you want to change. Do you want to go up and add? Do you want to go down and subtract? Well, I don't want to deal with decimals. I don't like decimals. So if I know I want to move my decimal point to the right versus to the left when I'm looking at these numbers, that means I'm going to need to subtract because I need to move right. So which one would you subtract from? Well, you would subtract from the larger one to bring it down. So if I take my number and I move my decimal point right, okay, and I only need to move it once because I only need to get it down to 2. So that leaves me with an 80 here. So now I have 80 times 10 to the second power. That is all one number. That is one value. Plus 5 times 10 to the second power. Now what I have here, these are the same. So I can just add 80 plus 5 and get 85. And then I write my power. So that might look like we're done. However, my decimal point is right here. In order for it to be in proper scientific notation, okay, it needs to move over. I moved it once to the left. So I have 8.5 times 10. Since I move left 1, I have to add. So this is to the third. Okay, so let's look at what this looks like with subtraction. Not much different. Again, this might help you whenever you're dealing with scientific notation to write it. Well, I think I want to get rid of my decimal. So that means I want to work with this one. And the reason why I'm able to do that is this is a 10 and this is an 11, meaning I'm going to subtract one of them. And I like that subtraction of the exponent because what it does is take this number. If I moved right 1, I'm at 12. But since I moved right, I have to subtract that exponent. So I end up with 12 times 10 to the 10th. So my new problem is 6 times 10 to the power of 10 minus 12 times 10 to the power of 10. So I really end up with 6 minus 12. That's a negative 6 times 10 to the power of 10. And that is okay. Okay, so now that we've seen it with positive exponents, I want to show you two examples with negative exponents because most of the time students tend to make mistakes when we're moving it and because we're adding with negatives or subtracting. So it's really in your best interest at this point to write our LARs on the side, because what this does is it helps us remember what we're doing. Now, when we're dealing with a negative exponent, and if I move my decimal place once, if I move it to the right, I'm subtracting. If I move it to the left, I am adding. So I want to just show you for a second. Negative 7 plus 1. This means I would have made a move left. That gives me the negative 6. But a negative 6 minus 1 gets me to my negative 7. So if you make a mistake, that's okay, but we got to stop and take your time. You can even use a calculator. Okay, so let's take a look here. And we need to, I think it might be easier if we take our negative 6 and subtract 1. So I would take 9.4. If I want to subtract 1, I'm going to move it to the right. So that gives me 94. But what that ended up doing, because remember, it was a negative 6. I moved right. Right is subtraction. I'm now at a negative 7. So I have 94 times 10 to the negative 7th plus 2.7 times 10 to the negative 7th. So I'm allowed to add now. Ladies and gentlemen, think of it as money. If I have 94 and I'm adding 2.7, remember your decimal points have to line up. So I end up with 96.7. And ladies and gentlemen, this could be on a non-calculator day. So these basic math facts you do still have to know. You're not done. Every time you do these, you got to stop and see if you are in scientific notation, and you are not. So I need to take this decimal and move it left once so that I get 9.67. Now I moved left. That means I'm going to add. I'm adding to this negative 7, I'm adding a 1. So I end up with a negative 6. Now I am done with this one. Okay, so here's what I want to take a look at. How this is going to come into play more so. In 2013, the national debt was approximately 1.8 times 10 to the 13th power. That's a large number. That's a lot of zeros. But in 2014, it grew by this much. So that's still a lot. So what it's saying is I started out in 2013 with this. Then there's a keyword grew. So that's going to signal that it went up by this much. They want to find the total debt at the end of 2014. So I'm adding them. However, if we take a look here, our exponents are not the same. So I'm going to, let's just take our, what do we want to do? We want to make 11 go up. So remember, Lars, left, add, right, subtract. Some of you might be saying, no, I actually want to make the 13 go down. That's what I would do. So I take my 1.8 and I need it to go down 2 to reach 11. So I'm going to move it. I need to subtract. So go over here and look here. If I need to subtract 2, that means I need to move right 2. 1, 2. So now I'm at 180 times 10 to the 11th, right? So it is okay to write a new problem. 1.80 times 10 to the 11th plus 3.3 times 10 to the 11th. Well, when I add, and that's my fault, ladies and gentlemen, it's not 1.80, it's 180. So when I add 180 plus 3.3, I get 183.3. Okay, so I have 183.3 times 10 to the 11th. Well, I'm not in scientific notation, so I move it back, and I get 1.833 times. Now, I went to the left, so I need to add, and I went to the left 2. There you go. Some of you might be seeing a pattern as to what way you should go. Should I go to the bigger exponent? Should I go to the smaller exponent so I don't have to change it? That's up to you. But you're going to want to move it so that you're able to add and subtract numbers without a calculator, whatever that takes. So you're going to attempt this one on your own, and I'm going to look for it. But I'm going to help you. I'm going to highlight some keywords. So here is Jupiter, okay? It's approximately 4.84 times 10 to the 8th power miles from the sun. Neptune is approximately 2.8 times 10 to the 9th power from the sun, or to the sun. We're talking about its distance from the sun. From, to, doesn't matter. They want to know how many miles closer to the sun is Jupiter than Saturn. And it must be in scientific notation. So you have to ask, am I adding or subtracting? What do you think you're doing? They want to know how many miles closer. I need to figure out what? I need to figure out the difference between the two. So the difference between the two means I'm going to subtract. Okay? So you're going to take this and subtract this. Okay? So I need you to attempt this one on your own. Now that we are done with this unit, we are going to practice it. So please make sure you load these notes and that you ask if you don't understand.